So we will first, hello everyone, myself Harsh Mehta, and I'm here to demo my personal project, which is multi-tenant SaaS application on AWS. As the project requirement, I have created the entire architecture in the Oregon region, that is in the US West, as it shows here. The next requirement was to create the VPC in this region. So as per requirement, I've created a VPC. These are the basic configurations related to VPC. The routing table associated with the VPC. This is the IP4, IPv4 address that are associated with VPC, name and ID, and other basic configurations. The next was to create subnets inside this VPC. So I have created two public subnets inside this VPC. So as it shows here, it is in the region US West 2A. The route table is same as VPC. Yeah, and it's a public subnet. Okay. The other subnet is also same as the first one. So it shows it's in the US West 2B. So the second availability zone is US West 2B. Yeah, the other configurations remains the same. I have created an internet gateway so that outside world can communicate with the VPC we created for the project purpose. So here are the configuration. Its ID and its corresponding VPC. The other configuration includes security group. Basically, this is created so that other instances and other components in the architecture remains protected from other unauthorized access of the outside world. So these are the ports open. This is for our RDS instance that is shared by all the four tenants. And yeah, these are the basic HTTP, HTTPS and SSH so that I can connect from my machine to the instance. Yeah, that's it in the basic configuration. Now we'll move towards the tenants. So these are our four tenants: Ubuntu tenant 1, tenant 2, tenant 3 and tenant 4. So like if we see configuration of any one of them, it is t2.micro instance, public IP, private IP. It is a subnet. In the subnet we created, which in turn is inside the VPC we created. It is the security group associated with the instance. These configurations are same for all the four instances, which in turn means all the tenants have same configurations. This is the key associated with these instances. Yeah, so now we'll move towards target groups. These were necessary to be created because we use them for routing in path-based routing in the load balancer. So these are four target groups. Like if we see the configuration for any one of them, it's exposed in 3000 port, and the targets, like if we choose select tenant 2, the target will be Ubuntu instance 2, Ubuntu tenant 2. Yeah, so as it shows, it's running and it's healthy. Yeah, that's same for all the target groups for all the four instances. The other important thing is the launch configuration is the basic configured AMI image we created for each instance, so it's the same. Now I'll move towards available auto scaling groups. Yeah, these are the four auto scaling groups that we have created so that in case the traffic increase on any one of the instance, it can multiply. The minimum number of instances I have kept as 1, and it can scale up to 3 instances. It can be in any one of these zones. And yeah, the target group associated with this auto scaling group is tenant 1 because we have chosen cluster tenant 1. So it shows here that it's tenant 1, which is tenant 1 target group that is associated with this auto scaling group. It is same for all the other remaining 3 auto scaling groups. So yeah, this is the load balancer, application load balancer I have created for the purpose of this project. So the availability zones, multiple availability zones. This is the endpoint DNS name that through which the entire world, the outside world can connect to these instances. Now the most important thing is here. I've configured the entire architecture on the basis of the URL. So like if the URL contains any word like tenant 2, it will be routed to the target group, which is routed to the instance which is corresponding to target group tenant 2. Similarly for tenant 4, tenant 3, and by default I have kept as one tenant 1. Yeah, so this was the path based routing. Yeah, that's it for the AWS part. Now we have also created RDS instance that is shared by all the 4 tenants. So we'll see that I've chosen MySQL as my database server. Yeah, this is the endpoint. Yeah, here we go. This is the endpoint for RDS. So I have created database. The database is as per this diagram. Here we go. Yeah. So we have 3 tables. First is tenant table, which includes information regarding all the tenants. This table has all the fields of each tenant table along with the type and their corresponding columns in the tenant data table. So these are the table. Basically it is implemented on the principle of extension column tables, so as to gain the scalability using relational database. So yeah, I can show, I have already created the tables, so I'll just show. This is our database tenant db, so I'll just type use tenant db show tables. Yeah, these are the 3 tables mentioned. So yeah, so for more better understanding I will start with the demo straight away. We can connect to our endpoint by connecting through the load balancer. For the simplicity purpose I will use user as grader and password as password. I'll select for tenant 1 to start with. Basically my first tenant is Anirudh. I will use test for the testing purpose, and see as it shows that it is in residing in the instance corresponding to the tenant 1. So like basically once we change the tenant, will this will change accordingly depending on the tenant we are grading. So I'll just check out his answer. Yeah, so this is the class diagram generated by running his code, Anirudh's code, and I'll just give some random scores, like I'll just give marks to be 80, this to be 90%, and I'll just press grade. Student graded certificate successfully. Now this data will be inserted in the database. So I'll just open up the select star from tenant data. as it shows the data is inserted inside this. So now we'll see for the tenant 2. We can do by signing out and uh, signing out, or else we can just do by URL. So I'll just change the URL for keeping it simple. I'll choose a file for testing purpose. This is for Sachin. Yeah, the second tenant is Sachin, and see the HTML page that is rendered over here has also changed according to the route. Just test URL. Perfect. So I've got the results for class diagram. The results are based on the code by Sachin. So I'll enter few random marks. 7.5. I'll just render 85. Grade it to be A plus. Grade. Yeah, graded successfully. I'll just check in the database. See, this is the result we got. Clicking on this grade table. Now we'll move to tenant 3. My tenant 3 is Divya. See, this is the page coming from third instance, that is Ubuntu tenant 3. It routed to tenant 3 because of the URL. Basically, load balancer acts as a interface between the outside world and the tenants or instances. I'll generate the image. Perfect. This is the image generated by running the code of Divya. I'll just enter marks and I'll just give some random comments. Good diagram. Just press grade. Check out again in the database. This is the third tenant. It is visible. Now I'll again say for tenant 4. I'll upload and generate. The UI is coming from 4th tenant. So perfect. This is for Raksha. Now tenant 4 is Raksha. I'll just grade it randomly. I'll just grade A, maybe 75%. I'll just write complete. Grade it. I'll just see. Perfect. So this is how all the tenants are handled using 4 different instances on EC2, and the request is routed depending on the path the user requests. So yeah, this is it from my side. Thank you.